Hello everyone and welcome to this video. So this is the last part of our platformer in Pygame. So we are going to be finishing this series up by adding power-ups, enemies and some clouds which will scroll. Okay, so it'll give us a scrolling background feeling. So let me show you what we did in the previous video. So this is what we did in the previous video. So in the previous video we did this. So we added music. So if you can hear, what we did is we also added jumping, and the jumping is much better now. So we didn't add the lighting effect is gone, so it stops snapping on top of the platform, and it's pretty smooth now. So now what we can do to finish up this game, give it a nice feel, is to add power-ups and enemies and clouds and everything. So I have got this boost sound called boost.wave. This is for the power-ups. So this is the sound for the power-up. So I'm just going to load that quickly and then we can create the power-up sound. So what we can do is we can duplicate this line or copy and paste, whatever you want to do. I'm going to call this self.boost sound. So that's because our power-up is going to be a sort of boost power-up. So it'll boost you upwards. So yeah, we're going to be using that. So in our sprites.py, I'm actually going to be copying this platformer class just so we don't have to keep on writing everything manually. So I'm going to call this class powerup, and then we don't need to have this we don't need this X and Y. Okay, we don't need the X and Y. But we do need a copy of the platform, because we're going to be spawning these power-ups on top of the platform. So here I'm going to say self.plat is equal to plat, and then we can get rid of these images, and I'm going to say self.image is equal to. So I'm going to be using where is it? This bunny. I guess that basically means you can jump higher. I'm just imagining that is. So I'm just going to be using that one. So that power up is actually that power up is called power up bunny, but I'm just going to imagine that it lets you jump higher. So that one is, we just copy that, and then here we say self.game.spritesheet.getImage, and then I can copy that and just tweak this bit a little bit so we don't have any errors. Okay, so let's tweak it, and then I'll tweak this again. There we go. So now what we need to do is we're just going to change these groups. So we're going to put game.powerups. So we're going to be creating that group. Okay. So we don't need to set these to X and Y because we don't have an X and Y parameter. We can also take this away. And then once we have done that, what we need to do is we are going to add a center X. So what the center X bit of our platform is. So self.rect.centerX, okay, is equal to self.plat.rect.centerX. So I'm going to be spawning it in the center of the platform, and then I am going to say self.rect.bottom is equal to self.plat.rect dot bottom. Okay, -5. So it's going to be kind of hovering above the platform a little bit, so it looks kind of nice. And then the last thing we want to do is we're going to add a update. So remember, update handles the behavior of our sprites. Okay, so the first thing over here that we want to do is we're going to say self.rect.bottom is equal to self.plat.rect.bottom. So we want to make sure that we keep it in the same position. And then what we need to do is we need to scroll these power-ups. We want to make sure, so when we scroll the window, as we are going to scroll the power-ups down, we want to make sure they get killed so our game doesn't have any lag. So what we need to do here is we need to say if not self.game.platforms dot has. So sprite groups have this method called has, and you can calculate whether a particular sprite is in that list, is in that sprite group. So if it does not have self.plat, then we're gonna kill the power up so that it doesn't bother us anymore. Okay, so that is actually our power up class done. But then we want to spawn it. Okay, so we're actually going to spawn it in the platform class. But then first what we're going to do is we are going to do something quite important. Okay, so what I'm going to do is right under our player properties over here, I'm going to put in game properties. Okay, so here we have, so I'm going to put, so the first one I'm going to put is actually boost power. We're not going to use this to we're not going to be using this to spawn our power up, but I'm just going to put it here so we don't need to create it sooner or later. So I'm just going to create it now. Gonna set this to 60. So yeah, the power up's gonna set the player jump to 60. So it's gonna set the player jump actually, or actually it's just gonna boost the player up 60 pixels or something like that. And then after we do that, we've got a very important bit called power up spawn rate. So this is the rate we're gonna spawn the power ups at, 7. Yes, that's pretty low, but they will spawn quite frequently. So they won't spawn too little, they won't spawn too much. So I'm going to give them a bit of randomness. Okay, so the first thing I'm going to do is, instead of importing choice, I'm going to import rand range along with it. Okay, so I'll just collapse that. Then down here, I am going to say if rand range, so rand range basically gives you a range from 1 to 100, I believe, is smaller than power up spawn rate. So this is how it's going to give us the randomness. Then we're going to spawn a power up. So I'm going to say power up. So the parameters we need to pass in is self.game and then self, which is the platform variable we need to pass in. Okay, so now we need to create the group, the power-ups group. So I'm going to say self.powerups is equal to pygame.sprite.group. There we go. And we've got our group. So I'm just going to put a space here actually. There we go. So let's see. I'm just going to go up and see. There we go. So now you can see we have the power up, but then it's spawning right in the middle of the platform. Okay. That's a bit that's a bit scary to look at. Well, not scary, but it's kind of weird. So we're going to want to change the location bit. So I am going to change it. I probably did it wrong somewhere. So we set it to self.plat.rect.centerx. Maybe it was the bottom actually. Oh, okay. So we're not supposed to set it to bottom. So got confused. We're supposed to put it on the top of the platform, right? Then we can check out. There we go. Now again, it is unfortunately it's still settling there. That is because in our update section we have to set this bit to top over here. I don't know why I'm getting so many silly errors. I'm sorry about it. Excuse my errors. But now we have fixed it. There we go. So now it is appearing on top. But now we can't collide with it anymore. So we're going to collide with it. Okay? So in our main.py, we obviously do everything in the update, even the collisions. So we're going to do the same here. So after we spawn our platforms to keep the same average number, what I'm going to do is I'm going to spawn calculate power up hitting. So I'm going to say pow hits or power up hits is equal to pg dot not pg pygame dot sprite collide. So the one we always use. So we want to collide with self dot player, self dot powerups, and then we want the power ups to disappear when the player collides with it. So we're gonna say for pow in pow hit. So for every power up that we hit, we're gonna say if pow dot type. Okay, so basically we were supposed to add that type over here. So I'm just going to quickly do that. So self.type is equal to boost by default. Okay, so I'm doing this so if you want you can add different sorts of power-ups. Okay, because there's plenty of images for that. So that's why I did this. So if self.powType is equals to boost, okay, if that's the case, then I'm going to say self.boostsound.play, and we're not going to put any loops in it. We only want it to play it once. And then we're going to say self.player.veiw.y is equal to minus boost power, so we bring the player up lots. And then we want to set self.player.jumping. We're going to set that to false so the player cannot jump while while the power up is shooting them upwards. So let's see what happens. Brilliant. So as you saw, that is working perfectly now. So now we're going to be adding enemies to our game. Okay, so along with that, I'm going to be adding a enemy spawn rate. Now, you might be surprised by the value actually. So let's not call it enemy. We're going to call it. Let me just undo that. I'm going to call it mob spawn rate because I'm just going to call them mobs. So basically, I'm actually going to set this to 5,000. Yes, 5,000. That's pretty high, but that doesn't mean they're going to be super frequent. They're actually going to be, they're just going to be as frequent as the platform, as the power-ups, but a little bit more frequent than that. So it's similar to power-ups, except the enemies we're going to add a different kind of moving system for the enemies. A very nice smooth animation. So we're going to give the enemies animation too. And when we are creating our enemies or mobs, we do not need to have a platform thing over here. So we can take that away. And then I'm going to actually call this one mob. And so we are going to be creating a game.mob mobs group. And then we don't need the self.type at all unless you want to have different enemies, because on the sheet there are quite some different enemies over here. Unless you want to do that, you can add you don't need to add a self.type. So what I'm going to do is I'm going to have a self.image up for the animation. So basically what I was thinking is for the animation, we're going to make the enemy go up, down, up, down, up, down, up, down. So it's a bit harder for the player to avoid. So I'm going to say is equal to self, and let's actually undo that because I don't know why I did that. So self.image up is equal to self.game.spritesheet.getImage. So what enemy am I going to use? I'm actually going to be using this enemy. So this will be the image up and this will be the image down. So it will look pretty cool. So the enemy is actually, let me just find it. It's called Flyman. Okay, pretty weird, but that's what it's called. So we need Flyman Fly. We need Flyman Fly and Flyman Jump. Okay. I'm just calling it image up, image down. But you should just be creative and just use what you can find to create it into very nice animations. So we'll just tweak this over here. There we go. And then here's self.image up.set color key. And now you can copy this to create an image down. So that one is, as I told you, is Flyman Jump. So we copy that and paste it right here. So let me just tweak this quickly again. There we go. And then we have to change this to image down now because this is image down. And then once we have done that, we do not need the self.right.centerx and self.right.bottom anymore. So now what we need to do is, actually we do need the self.right.centerx, okay? So the centerx is going to be random, okay? It's not going to be just the same every time, it's going to be random. So also what I was going to do is I'm going to say self.image is equal to self.image up. So we're going to set it to image up as a default. So as I told you, the centerx is a bit random. So we're going to say centerx is equal to choice. So we're going to give it this choice of numbers. So -100 or width plus 100. So it's going to appear a little out. It's going to be a little out of the screen on the right or a little out of the screen on the left. So this is the left, this is the right, sorry. So it's going to be over there. So we want to make it appear a little bit off the screen. We don't want it to just appear suddenly. We're going to make it appear off the screen so the player it doesn't give the player too much of a shock. And then what we're going to do is we're going to add some variables for the mob movement. Okay, so I'm going to say self.vx. So this is the velocity in the x direction. So vx is equal to rand range. So this is randomness again. So either 1 or 4. So it'll move in one of those speeds. So 1, 2, 3, or 4. okay, because it's round range, not choice anymore. And then we're going to put in a self.rect.y. So this is going to be round range or height over 2. So it's going to appear in the top half of the screen, somewhere in the top half of the screen. And then you want self.vy, which is going to be the velocity in the y direction. We're going to set that to 0. And then we're going to say self.dy, which is going to be the increase. This is how we're going to increase the mob movement, because we're going to actually make the mob go up a bit, little bit by little bit. So we're going to set that to 0.5, so it goes up a bit too. And then we are actually going to set one condition here. So over here, we're going to set one condition. So that one is if self.rect.center_x is greater than width, then self.vx times equals 1. So that should be going faster when it has gone off the screen. Okay, that's probably what it does. And then now in the update section, we're going to take away all of this. So first thing we want to do is we want to handle the movement. So the X movement is very easy. All we need to do, so I'm just going to write a comment here saying X movement. So as I told you, the X movement's easy. Okay, so keep on missing my keys. There we go. So what we need to do is we need to say self.rect.x plus equals self.vx. Okay? So basically that's pretty easy for the X movement, and the Y movement is the hardest actually. So I'm going to say Y movement over here. So the first thing we want to do is we want to increase the Y a bit. That's easy. So self.vy plus equals self.dy. And now we're going to make the player make the mob move using this calculation. So I'm going to so before we do that, I'm going to say self.v. So I'm going to put a condition here. So if self.vy is greater than 3 or self.vy is smaller than -3, okay, then we're going to say self.dy times equals 1. So we'll just make sure it doesn't go at different speeds sometimes. And then we're going to say center is equal to self.rect.center. So then we just reassign it so it keeps the same. It doesn't go anywhere too much. It just follows the calculations. And then after that, we're going to do the animation here. So it's very different to a player animation. So we're going to say if self.dy is smaller than 0, so that means if it is going up, well, not going up, just if it's smaller than 0, we're going to say self.image is equal to self.image up. Okay, so and then after that we say else. We're going to say self.image is equal to self.image down. So that will give us a kind of bouncy effect. And then what we need to do is finally we can add the movement. So we can add the movement using this calculation over here. What we can do, so how we do that, we just say self.rect.y is equal to self.vy. But we want to make sure the rect does not change all the time. So we can prevent that by saying self.rect is equal to self.image get rect. So we need to do this frequently so we can make sure the player, the mob does not just move in random places. And then we want to frequently keep on changing the center as well by saying self.rect.center is equal to center. So yeah, that's what we do. And then that should fix the movement. And then we also want to kill the mob when it goes off the screen on the other side. So we're going to say if self.rect.left, if it is greater than width plus 100, or self.rect.right. Let me just remove this comma. Self.rect.right. If it is smaller than minus 100, so that basically means if the mob goes off of any of the sides, so not the side it started on, the side it's trying to go to, then we want to kill it. So self.kill. Okay? So that is the movement covered, and then we need to start spawning the mobs. Okay? So I'm not going to be using any sort of rand range thingy over here anymore. I'm actually going to add a timer, so we can spawn the mob when that timer starts counting. Okay, so in our new section over here, above here, I'm going to say self.mob timer is equal to 0. Okay. I'm just going to put a space over there. There you go. So now I'm just going to collapse that over there. And then in our update, we can now start spawning mobs. Okay. So here I'm going to say spawn a mob. So this is when we want to spawn a mob. So I'm going to add a now is equal to pg.time.getTicks. So now we can keep track of time. So I'm going to say if now minus self.mob.timer is smaller than mob spawn rate plus, so this is how we get the randomness, plus random.choice. So now we can choose, now we have a choice. So our choices are minus 100, 1000, sorry, minus 500, 0, 500, and 1000. Okay. So those are the times. So it will appear at random intervals. So we're going to say self.mob timer is equal to now. And then we spawn a mob. So we spawn a mob and give it a copy of the game. So let's just put the code on here and start checking out. So that has given us an error. Game object has no attribute called mob. Mob spawn rate, self.mob timer. So not self.mob.timer. Sorry, excuse my errors. So again, that has given us an error. Game object has no attribute to mobs. Okay, that is because we forgot to create the group, didn't we? So in our new over here, we need to say self.mobs is equal to pygame.sprite.group. And then we've got our mob group. It has to work now. Let's just wait. There we go. But now you can see it's moving down instead of up, and the animation is not actually working. Okay, so let's check what we did wrong. I'm just going to check. So, I'm just going to quickly just scroll through. So the error must have been in the update section. So self.vy plus equals self.dy. So we do that, and then we say if self.vy. I'm just gonna come back once I've checked. So I went through and I just realized that it was another silly mistake. So here it's not times equals 1, it's times equals minus 1. And then here, instead of saying self.rect.y is equal to self.vy, it's plus equal to. Okay? So we'll check it out. So basically, if you just wait for an enemy to come, you can see now, if we jump, the enemies actually look chasing us. It's kind of weird when that happens. So what we're going to do is we are going to have to scroll them down, like we did for all the other sprites. Okay? So we'll just close this. And then here, where we when the player reaches the top fourth of the screen, there we have to scroll it down, right? Like we did for all the others. So here I'm going to say for mob in self.mobs. So for every mob in our self.mobs, we're going to say mob.rect.y plus equals the maximum value of the absolute value of self.player.val. Okay? .y, actually, not just val. We're going to do it by 2. And then we'll check. So let's see if they... Yep, so they do scroll down. So now we want to collide, check for collisions with the mob, because what's the point of having a enemy or a mob, whatever you want to call it, when you can't just like, when it doesn't harm you when you touch it. So again, I'm just going to write here, check if player hits a mob. So how do we know when a player hits a mob? Again, we're going to be using our sprite collide. So I'm going to say mob hits is equal to pg is equal to pygame dot sprite collide. Okay, so we're going to put self dot player. We're going to put self dot mobs. We don't want the mobs to disappear. And then let's just put spaces here. So we've done our mob hits now, okay? So we're going to say if mob hits, then we're going to set self.playing is equal to false. Okay, so not self.running, self.playing. So then it takes us to a game over screen. So let's see. I'm just going to wait. Well, there's one error about that now. So let's see. Basically, if we just wait for a mob to come. So if we jump, the collisions actually aren't that perfect. So we want something called pixel perfect collisions. So this is where we where it looks for the pixels and it actually collides exactly. So before we do that, I'm going to show you quick. I'm just going to show you a quick presentation. So One question you might be asking, because some people think that doing pixel perfect collisions are hard. Well, they're not. So before that, we're just going to look at any different ways. So there are 2 other ways for this, so let's see them now. So basically, number 1 is to use the usual default way, which is using a rectangle to collide, okay? But instead of using rectangles, we could use circles, okay? So that's possible too. But now you can see that the circles or ovals, they are quite bigger than the rectangles. So number 2, if you don't like that, you can resize the circles and rectangles or squares. So you could do that, but now there's these bits that stick out, and that could cause the player to cheat. Okay, so the last thing is to use a mask. Okay, that's the easiest way. So how do masks work? So let's say we have our enemy over here. So this is what a mask is. Basically, it is this. So if I show you, we have our mob, and then we have this. So this is basically like a silhouette of the mob, and that is applied to a mob. So it looks at all the pixels and makes a sort of silhouette like that, but it's transparent. You can't see it. And then it checks if you're colliding with that silhouette or not the rectangle around it, the silhouette. Now the problem with this is that if you have too many of these, it can make your game quite laggy. So what you can do to fix this, well, we don't need to do this, but if you are using loads of mask collisions, we're actually not. We're just going to do it with the enemies. So if you're using loads of mask collisions, then what you can do is you can first check if they're colliding with the rectangle, and only then you can start using masks, okay? So yeah, that's what we're going to do. So let's do that. Okay, so here we are, back again. Basically, basically what you can do is we can use a mask, right? So using a mask is actually not hard, okay? So as I told you, loads of people think it is hard, but actually it isn't. So what we need to do is we need to do this. So in our player, we're going to do it to the mob too, don't worry. So first we're going to do it in our player. Okay, so we are going to say over here, it's not very hard, remember, so don't worry. What we need to do is we need to say self.mask is equal to pg.mask.fromSurface self.image. So the from surface over here basically means what surface do you want to draw this mask on? And basically you might be thinking, how do we let the computer know that we're using a mask? Well, we don't actually need to let them know. Basically Pygame looks for this, and then if there is, then it knows that there's a mask here. So we can copy this now and put this in the enemy area, in the enemy class too. So I'm going to first collapse this, and then I'm going to put it in the mob or enemy, whatever you want to call it. So I'm going to do it here. And there we go. So let's check it now. So here it is. So first we're going to collide with the enemy. Oh, I missed that one, sorry. Okay. I'm sorry about that, guys. I keep on missing it. There we go. So now that you could see, that was a pixel perfect collision. Pixel perfect. So that is perfect now. And then there's one more thing we need to fix. Basically, sometimes the enemy comes in front of a platform and behind a platform. So let's see. So this one comes in front. And then let's look at the next one. This one comes in front too. They all come in front, but actually some come behind. So okay, but it looks a bit weird. Okay, it looks actually kind of very weird. So what we can do is basically there's something we can do to our sprites group to fix this. Okay, so what we need to do is in the new, so first I'm going to close that. In the new over here, for the all sprites, we're going to say self.all sprites. We're going to not set it to group. It's going to be like a group, but it's called layered updates. So now we can add sorts of layers, so we can control our sprites and know what layer they are on. So I'm going to create some sprite layers over here. Okay, so I'm going to create those. So first I'm going to create a player layer. So I'm going to set this to 2. So this is we should be seeing this above all in front of everything. So we're also going to create the mob layer. This is also going to be 2. So the player and the mob are on the same layer. And then we are going to create a pow layer. So pow layer is equal to 1. So that's going to be behind the player. The platform layer is 1, 2. So yeah, that's what we're going to do. And then now we need to know that there's some layers. We need to let our sprite know that we have layers. So again, it's like the mask. Our Pygame looks for these layers. So self.underscore layer. Okay, you need to make sure you call it that. We're going to set this to player layer. And not pow layer. Player layer. Or did I spell that wrong? No, I didn't. Okay, that's fine. So we created the layer. We can copy this and paste it everywhere. Now just change the layer name. So now in our platforms, we want to insert the layer. Make sure you do it before groups. So instead of player layer, it is platform layer. And then for the power ups, it is pow layer. So instead of player layer over here, it is pow layer. And then over here in the mob section, it is mob layer. So now everything should work out just fine. So let's check it. So now the player is in front of all the platforms, and so are the mobs. So that's amazing now. Now one more thing we need is we need to add the clouds. So I have these cloud images. I'm not going to be using the cloud images over here because the cloud image over here is kind of an evil cloud. I don't like it. So I've got these clouds, cloud 1, cloud 2, and cloud 3. Okay, so these are the clouds I'm going to be using. So we are going to have to create a separate class for these clouds. Okay, so I'm going to say class cloud. Actually, what we can do is we can copy the power up bit over here. And then what we need to also do is we need to create a cloud layer. So cloud layer is equal to 0. So it'll be all the way at the back. So where is, so here we're going to call this sprite cloud. And then we're going to replace this with cloud layer. And then we're also going to be creating a group called clouds. Even though we're not going to be detecting collisions, we still need that so we can move the clouds about. Okay, self.cloud layer. There you go. We don't need this type we don't need platforms over here. So we can take away the plat bit. We do need a copy of the game. And we're not going to have, so we're going to say self.image. We're going to actually set this to a choice, okay, of self.game.cloud images. Now, basically, we're going to be creating this later. First, we're going to just focus on the cloud bits. So, we are going to be creating a variable called a scale. So we're going to say scale is equal to rand range 50 to 101. It won't include 101, don't worry. And then we're going to divide that by 100. So let me just spell that. There you go. So the reason I created a scale is so the sides are all different. Clouds are all different sizes, and it's quite nice. It's quite a nice variety. So now what we need to do is after that we need to say self.image is equal to pg.transform.scale. I'm going to scale self.image, and then we need to put the width and height we want to scale it by. So the first width, first for the width, I'm going to scale the self.width, and I'm going to times that by scale. And then, so it's not self.width, that's actually it's self.rect.width. And then for the height, it's the integer value of self.rect.height times by scale. And that should give us the size of the cloud. And then here, I'm going to say self.rect.x is equal to rand range. So we're going to say width plus 2 minus self.rect.width. So we just have to make sure that any excess clouds are not off the screen, they're still on the screen. And then we're going to say self.rect.y is equal to rand range minus 500 and minus 50. Okay, so that should be they will appear above the screen, but then we're going to actually be scrolling down on them so that we see them. Okay, and then in our update it's similar but it's not the same. Okay, so we don't need the self.rect.bottom anymore. So all we need to do over here is we need to say if self.rect.top is greater than height times 2. Let's just spell height correctly. No, I did not spell that correctly. Oh. So if self.rect.top is greater than height times 2, then we're going to say self.kill, so we don't have to handle too many clouds. So now that we have done that, we need to go ahead and create this cloud images over here. So we'll do that. So in our load data, I'm going to do this over here where we did our sprite sheet. I'm going to say load cloud images. Okay, so we're going to say load cloud images over here. So we are going to actually create some sort of index so we can load that cloud image into the game. Okay, so I'm going to say self.cloud images is equal to this. this empty list, okay? So we're going to be generating an ID so we can load that ID into the game. So that ID is going to be the name of each cloud image. So I'm going to say for I in range 1 or 4. So it's not going to include the 4. It's only going to go up to 3. Okay? So we're going to say self.cloudimages.append pygame.image.load. So we want to generate the path, remember. So path.join. I'm going to join the image directory. And then this is where we generate the cloud ID. So we're going to use f strings for this, or dot format method. So we're going to put in cloud, and then that I, we're going to put in I, so that's going to be the number, dot png. So that's going to be the cloud, and we're going to append that. So now that we have our cloud images, we can, what we can now do is we can actually spawn a cloud. Okay, so yeah, let's do that. So what I'm going to do is I'm going to spawn the cloud when the player scrolls. Okay, so right at the top over here, even before we scroll the player to, we're going to say if self dot if random dot rand range 100 is smaller than 10, then we're going to spawn a cloud, and then we need to pass in copy of the game. And now we need to scroll the clouds. So now we need to scroll the clouds after the player. After you scroll the player, so we're going to say for cloud in self.clouds. Now we have not created that. We haven't created that group. So in the new over here, we need to say self.clouds is equal to pygame.sprite.group. Okay, so that's that, and then finally we can finish this up. So for cloud in self.clouds, I'm going to say cloud scroll is equal to random.rand range. So we're going to scroll them at random, so it looks like so it feels like actual clouds, and it's quite natural. So we're going to scroll this now. So we're going to say cloud.rect.y plus equals the maximum value of the absolute value of self.player.veiw.y divided by cloud scroll. So now we can add in the randomness, and then we're going to pass in 2 over here. Okay, so let's see if they scroll and spawn. So that has given us an error, unfortunately. So it's because of this silly error over here. So rand range. There we go. So now you can see okay. So these clouds look pretty good. Okay. So yeah, these clouds are not working now. But sometimes, as you can see in the background, the clouds are actually sometimes just scrolling themselves. Okay, so they're just like randomly scrolling themselves. That is because now here we need to put max around this absolute value bit. Okay, so now we need to put maximum value. Okay, and then we need to pass in the 2 over here. Now the cloud should stop moving by themselves. problem that there aren't any clouds when we start. So we are going to spawn some clouds when we start off the game. Okay, so we obviously have to do that in new because we do it when we start a new game. So again, that is not hard. It is pretty easy. It's only 3 lines of code we need to do. So I'm going to do that after we load the music. So I'm going to say for I in range. So I'm going to spawn about 7 clouds on the screen. So for I in range 8, C is equal to cloud. We obviously have to pass in a copy of the game. And then I'm going to say c.rect.y plus equals 500. So now they should spawn on the screen. There we go. Now we've got a few clouds on the screen. So now those clouds are okay. So that's pretty good now. So yeah, that's all I wanted to. So that's basically the end of this series now. So we have learned so much. We have used more advanced things like classes, and yeah, it's been very great learning stuff like this. So I hope you like this series. If you like the series, please like and subscribe, and also comment down below for any comments. You can ask your questions down in the comment section as well. I'll be happy to answer them. If you like this video, please like and subscribe. I think I already said that actually. And yeah, I guess that's the end of this video. I'll put the link for the sounds. I'll put the link for these cloud images. And I'll also put the link for the whole project itself. Okay, so yeah, I guess that's the end of this video. Bye, and thanks for watching the series.